Hi, I'm Mrs. Mirczak, and I teach Trig at Reno High School with Mr. Goodfellow, and I'm going to try to anticipate some homework questions that you might have when you're doing Math Excel. So I'll always put the number right up here so you can kind of zoom through the video and find the questions that you have questions on. Okay, so here's the first one. It's number 4. My numbers might be different than yours. I think that's how Math Excel works, but hopefully the concepts will be the same. So after you kind of like plug in some numbers, like this one's the I or N or whatever letter they use, you kind of get this big thing with fractions, and it asks for a single fraction. So a possible hint might be like, let's go ahead and distribute the exponent to the top and do it out, so -2 to the first is -2. But let's do on the bottom, just leave it as an exponent, and I'll tell you in a sec. -2 squared is 4, and 7 squared is 49, but let's leave it 7 squared. And then -2 to the third, I'm nervous, is 8, -8, yeah. And 7 to the third, and then 16 and 7 to the fourth. Okay, so we have to get a common denominator to squish all these fractions together. 7 to the fourth is 7 times itself 4 times. And 7 to the third is 7 times itself 3 times. If we want them all to be the same, this one needs an extra 7. And so whatever we do to the bottom, we have to do to the top. And then this one has 2 7s already, but it needs to have 4 7s to be the same denominator. And so just give it a couple extra 7s, and that way we're not having to do like all the math out. And this one needs 3 extra 7s. And then once you have that going on, like multiply each of these tops, and then it can be over this bottom. And then the tops you can like add together once you do that, and then the bottom will stay the same, and that might be a little quicker than working with really huge numbers. Okay, so the next one's number 5. And the weird part about number 5 is in the formula, there's no letter, there's no variable, there's no I. So when I is 5, what's 8? Isn't it just 8 still? What about when I is 6, as this ticks up 1? 8 is still 8, but we're summing them, we're adding them. And when I is 7, 8 is 8. When I is 8, 8 is 8. And lastly, when I is 9, our stopping point, 8 is still 8. So add those up, and that's it. Okay, so on number 6, you might have to find yourself adding up a lot of fractions with different bottoms again. So this is like a few steps in. But again, maybe don't multiply out like 6 times 5 times 4 times 3 times 2 times 1 to be 720. Maybe let's just think of it kind of deconstructed so we can see what's really going on in the math. So that's this bottom. And 5 factorial is 5, 4, 3, 2, and 1. And if we want to get a common denominator, this one's missing a 6. And now their bottoms are both the same. They're both 720 if you multiply them out. This one is 4 factorial, so 4 on down. And it's missing a 6 and a 5. So whatever you do to the bottom, you have to do to the top. And just keep going on down like that, and then the tops you do out, and then the bottoms are all the same, so you could add them together. Okay, the next ones are 8 and 9. They want you to use I as the variable. It says it in the directions, but we're kind of used to using N's or K's or I don't know. But they want I's, so make sure you use the right letter, otherwise it gets picky. Okay, so number 12 is a little different because there's like a lot of letters going on. So there's I's and there's N's also. And so if we kind of look at this pattern, like 2, 3, that seems to be ticking up by 1. Maybe there was an invisible 1 there, an invisible 1 underneath. So the 1, 2, 3 goes all the way up to some letter N, and then 1, 2, 3 goes all the way up to some letter N. So they want us to start at 1, for I is 1, and they want us to go all the way up to, and in this case it's a letter, it's letter N. So that's kind of different. And then as far as the general formula goes, we have 2 to the something over that same thing. And they want that thing to change. See how it's 1 now and 2 later and 3 later and N after that? So that's going to be our I. So I know this has N's in it, but the I is the thing that's changing. And so we want to fill in that this is 2 to the power of I over letter I. So there's I's in here and not N's, so that's kind of different. Okay, 13 and 15, super picky. Once you get your little formula going on, you have to have parentheses around it in 13 and 15. I don't know why, but it like counts it wrong otherwise. So use some parentheses around your little formula. And I'm going to talk more about 15 in just a sec. Okay, 15, we have to find a pattern. And like Mr. G said in the videos, we kind of want to look for like if it's adding or subtracting or multiplying or dividing. Those are some of the more common patterns we kind of know of. And we notice here maybe that it's adding the same thing every time. It's adding 3 each time. And so this is actually a linear pattern. It's a line. So remember y equals mx plus b? What's happening every single time is the slope. And so every time we go over one more step or jump or click, we have to go up 3. And so that's the 3. I'm going to put an X here for now, but we'll have to change it later because they want K's. And then the B is the y-intercept in, Algebra 1. And the y-intercept is where it hits the y-axis. And on the y-axis, x is 0. And in our patterns, we usually start when x or n or k is 1. And so let's go back a step and find when x is 0. And the pattern is still the same, so it's adding 3 every time. But what number would this have to be so that when we add 3, we get to 4? Isn't that like a 1? And so that's this b, 3x plus 1. So here's like a way to find the pattern using linear stuff from Algebra 1. And then when we put it over here, we'll just change it into k's. And then the last part is this has to tick all the way up to get 37. So 3 times some k plus 1 has to be 37. I know 3 times 10 is 30. That'd be 31, so that's a little small. Maybe 11, that's 33, 34, maybe 12. 3 times 12 is 36, plus 1 is 37, so I'm thinking that that one will be 12. So there's a hint on that one.